Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking Looker for sponsoring today's event. Looker is a new sponsor to the DSC family, and we are honored to have them sponsoring our webinar today. I would also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including MapR, Teradata, Tableau, Oracle, Pivotal, and Cisco, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you've not had the opportunity to view them, I would encourage you to do so, as they do provide some very useful information. Today's webinar is entitled Improving the Data Modeling Workflow, and before we begin, I'd like to briefly review the format of today's webinar. Today's event will be approximately 1 hour long. We have two panelists that I'll introduce to all of you in just a few moments. We should have about 10 to 15 minutes for Q&A following the presentation, and this event is being taped and will be made available later on this afternoon at datasciencecentral.com. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host for today's webinar. I'm very pleased to introduce our speakers, Colin Zima of Looker and Justin Palmer of LendingHome. Colin is the Chief Analytics Officer at Looker, where he employs data to drive better decision-making across businesses of all sizes, including high-growth startups and large corporations. Prior to Looker, Colin served as the Director of Data Science and Business Intelligence at Hotel Tonight, which he joined through the acquisition of his startup, Primatable. Colin also spent several years as a statistician at Google in search ranking. Justin is the Director of Credit at LendingHome. He led speech recognition and natural language processing R&D teams at MITRE and Basis Technology. He consults on machine learning and data science and founded an email productivity startup. He earned his Master's of Science in Computer Science at Brown University. Thanks for both being with us this morning. We're looking forward to your presentation. The core competency of an effective data scientist is producing direct value for businesses via quantitative models. New analytic tools allow the data modelers to drastically improve data modeling workflow, speeding up data cleaning, identifying and exploring predictive factors, and rapidly evaluating and analyzing results. In today's webinar, Justin and Colin will look at ways to speed up the dirty work around building data models. They will dig into the key steps in the process and offer ideas and examples of improvements. So Colin, since you're starting us off this morning, I'm going to turn it over to you, and you can begin as soon as you're ready to go.
Perfect, thanks. Hello, everyone. Pleased to be here talking about data modeling. So right off the bat, give the quick 30-second pitch for Looker. So Looker is a data exploration platform. We help people explore SQL databases with a reusable code path so that people can more quickly get at their data and push it out throughout the organization. We work with lots of different partners, from big companies to small companies, and we work with everyone from data scientists all the way down to analysts and completely non-technical people. We try to be the right solution for everyone at the same time. So Justin, tell us about LendingHome.
So LendingHome is, we're a brand new mortgage bank. We're building a mortgage bank from the ground up with a focus on a really great borrower experience. And we also have a mortgage marketplace where people can invest directly in mortgages. So we like to think that we offer, the best absolute experience for borrowers. Instead of a paper-driven process, we have an online electronic process, and investors can hold money with us instead of in a savings account and earn interest and actually earn interest rather than what you would normally get from a bank or a CD, which is pretty low these days. But in order to make that experience really great and seamless both for investors and borrowers, there's a lot of data work behind the scenes that happens, and we drive all of it through Looker pretty much. So our entire operations team Getting a mortgage loan done is highly regulated and complex. That workflow in our operations team is driven by Looker. I'll show you some examples of that. Some really gnarly SQL that Looker makes. It's really hard SQL. It would not be doable without Looker, but now it's doable. And not only is it doable, but we have about 30 operations people that use Looker every day, every minute of every day, really. And then on the other side of the house, when it comes to data, we have pretty heavy statistical modeling processes for driving our credit and underwriting models, but also for figuring out what are effective marketing campaigns. So I'll go through kind of two flavors of data at LendingHome and show you how Looker folds into both.
Cool. Let's get into it.
Okay, so just some sort of an overview of things that we've accomplished. We've actually closed a mortgage in 72 hours, which is pretty incredible. If you ask any mortgage bank, the typical turn time on a loan is 45 days. We have a very efficient short form where you can essentially get a rate in 3 minutes, and that's a rate where it's a pre-qualified rate that we'll honor. And investors also get to, they leverage our experience as an originator. So our typical yield on a loan for an investment property is between 8 and 14%, which is a pretty nice gain compared to the normal savings account. And that's all electronic. You don't have to wait to get your money. As soon as borrowers pay us, we pay investors out.
Cool.
And I mentioned our operational process is pretty involved. There are approximately 100 items that our ops team, all the way from processors who just make sure that your file as a borrower is complete and thorough, to underwriters who are really looking over the more detailed bits of those loan files, to the closing team that takes care of title and insurance and wires money. That's all a pretty data-driven process here. We optimize it. We're constantly looking for efficiencies and inefficiencies and making that turn time even faster. We'd love to be able to get to a 48-hour close. That would be incredible, but and that's sort of our goal operations-wise. And this whole thing, like I mentioned, I'll go into a couple examples right off the bat here, but it's all driven by Looker. So here's one of them. When a borrower comes to our site and fills out a loan application, they typically give us they have a property in mind, they've got a date that they'd like to close on it, and that's really about it. They have a bunch of other personal information, but once they hand it off to us, we have a lot of work to do. And so what our ops team and our ops managers see is a set of reports that look essentially like this. So this is a grid saying, for every loan in the pipeline, what do we need to get done to get the loan closed? And so imagine essentially about 10 other reports just like this. And each one of these columns tracks something critical to the process. So it's ordered by the date that we expect to sign on the loan. And when you see blanks all the way across, that means we've done everything. When you don't see blanks, that means we have stuff to do on that loan. So for example, on row 8, where this was created a few days ago, but we had some loans to close on the 23rd, and we had a few long pole items like this, the flood process we haven't kicked off yet, so we needed to order flood for one loan. We also hadn't done title for a loan, or we hadn't requested hazard insurance either. And you get the idea. There are a lot of these sorts of things that have to happen, and it's all driven from that 96-item checklist plus a bunch of documents that we need to get on file. So this is a really terse top-level view of kind of what's in the pipeline and what needs to get done. And I want to show you the SQL behind this, just because it's It is really, really gnarly. So this is about 100 lines of SQL that Looker generates. And if you notice the scroll bar on the right, that's probably about 1/10 of the screen. So I think that this query checks in at around 1,200 lines of code, which is just crazy. There's absolutely no way that we could ever manage it without Looker. But instead, the previous screen that I showed you is used by about 30 people. They probably run that query every couple times every hour. So this is the sort of thing that we do to run ops. It really pushes the boundaries of I think it pushes the boundaries of what you can do with a tool like Looker that gives you a nice abstraction layer on top of SQL. And we have timings for all of these things as well. So we do, every time that somebody clicks an order, for example, for an appraisal, we have an automated appraisal service that we call out to. We measure how long that takes, right? We measure how long it takes us to order it and how long it takes our service to perform that appraisal. So we have complete visibility into efficiency, and we track it all. We track it all here.
Yep. So kind of to bring it back, data scientists create most of their value by modeling data. So by taking a bunch of inputs and trying to figure out or predict something in the future that creates actionable value for the business. The key is that a lot of things that analytical tools are good at, like creating complex models or machine learning or things like that, are not you require clean data for. So the New York Times recently wrote an article about how data scientists spend 80% of their time cleaning data. Any data scientist that's worked with any data from the real world knows that this is kind of a constant challenge. So this is kind of my quick workflow, but the big block in the center, data cleaning and shaping, that's kind of the work part of data science. The good stuff is really the model development, defining goals, trying to decide what is going to be modeled. That's kind of where the expertise of a statistician or a data science lies. So anything we can do to improve that data cleaning and shaping workflow is going to let a data scientist focus on their core competency more. And the same goes for kind of model eval. Once you've created a model, tracking it over time, evaluating residuals and things like that, it's kind of the work portion where developing the model is really kind of the exciting part of what we're doing. So SQL can be a very effective tool for taking all of this data and cleaning it up, but again, writing raw SQL can be very difficult. So having this abstraction layer to clean data can make things a little bit quicker. I know analytics is not something that data scientists like talking about, but there's a reason that people do these basic analytics off the bat. It's because you can learn lots of things before you pump things into your model. Kind of creating models that are well understood is a more effective way to create models, because when you can explain things in the real world, they're kind of more founded in truth versus kind of black box model development. So in this quick example for the presentation, we looked at 38 million flights between 2000 and 2005. The FAA maintains a fairly rich database of every flight that happens and kind of every attribute you can possibly imagine about a flight, just stored in typical SQL tables. So we tried to model on-time rates. So kind of one approach is that you could just take all of the data, stitch it together, and shove it into some sort of machine learning or black box, and then it would spit out some sort of multi-factor model that would predict on-time rates. But I think most people would agree that taking all of this data, modeling it, so understanding how the joins work together, and then exploring it is probably typically what most data scientists would do. So rather than just push all of the data into a black box and start modeling, what you're going to try to do is start to understand the relationship of different variables to on-time rates. So this is just a quick view of carriers and their on-time rates, day of week and their on-time rates. Everyone's flown and they know kind of the typical things that would cause a plane to be delayed: time of day, day of week, day of year, carrier. So what pushing this into an analytics tool lets us do is kind of point and click explore our data. So we can take this data underneath, and we're going to be querying our databases directly so we know we're getting at the raw data. We can model all the connections together, and then we can just browse. So right here, we took a look at hour of day and the impact that the hour of day has on time rates. And this is a little bit small, but we noticed that on-time rates were terrible at midnight. So this is on-time rates modeled by hour of day in blue, and you can see this kind of spike downwards. And the number of flights is the green here. So we know that on-time rates are awful at midnight, but this doesn't quite mesh with what you'd expect in the real world. We kind of know that there's going to be a smoother kind of transition between on-time and not on-time flights. So what we can actually do, because we have the raw data, is explore it. And this models up hour of day versus the flight status. So each column is a different flight status. And what we notice is that every single canceled flight is actually assigned a departure time of midnight. So all of our canceled flights actually occurred at midnight in our database. And this might be something that this isn't things that you can't do outside of your analytical tool like R, but when you can quickly explore the data, drill in, and observe row-level data kind of through a web UI, you're going to be able to get at these quick conclusions faster. So what we can now do is take this data, remove all of our canceled flights, or remodel what the definition of an on-time flight is, and we've quickly got cleaner data that we can pop into our analytical tool. So this kind of drill in, drill out, slice and dice is something that is typically done by a less technical kind of analytical person, but it can be a very effective strategy for doing data science because the same conclusions are important. We need to understand why things are happening. We need to look at outliers, and we need to browse. And tools like R or Python may not be as effective as an analytical tool on top of our data. So this kind of extends to kind of correlated relationships as well. So again, we can take all of our data and push it into a black box model and have R try to tease out how variables interact, and we can slowly eliminate variables. But if you wanted to test kind of codependence between every pair of variables, that's going to take an enormous amount of time, and we might not draw conclusions that logically make sense. But again, when we can browse data and look at collinearity together. So right now what we're looking at is just kind of a handful of different charts, again, exploring the same data set. So at the top, we've got hour of day on-time rates for 2 different airlines. And we can see that there might be some interaction between time of day and carrier. So if there is a relationship between these two, we're going to want to reflect that in how we build our model. By the same token, we've got distance of flight and carrier over here. So one carrier degrades much more in terms of performance with distance than another carrier. Is that something that we'd want to include in our model? And kind of how do we want to bucket distance? If we can quickly adjust our buckets on the fly and just make simple graphs and observe trends, then we're going to be able to model a little bit more quickly and logically. And then kind of the third graph over here is a quick view of day of week and different airports. So this is the airport that our flight took off from, and the on-time rates by day of week. And we see, again, something that's very intuitive, but we can observe in the data, which is, does the airport affect this day of week trend? And we know that some airports are leisure airports and some airports are business airports. So it does actually make sense that there might be this relationship between the two. But through analytics, we can kind of explore this relationship before going out and modeling our data. So kind of to summarize, analytics can kind of help us understand our data a little bit more quickly, and it can also do some things that we might not like in our analysis tool. So date functions are notoriously difficult, and if you're modeling your data prior to doing date shaping, that's going to be something that's effective. This idea of a subselect function, so if we want to create fact tables about flights, about planes, specific airports, that's going to be more difficult in our analytics tool, where SQL is built for a lot of these different things. So if we're doing this kind of pre-processing before we pop our data into a modeling tool, we're going to be able to model a little bit more quickly and effectively once it's there. So Justin, you want to tell us about kind of how you've done this in the real world?
Sure, yeah. So I'm going to focus on one example, our credit model. So we have a historical data set of around 25 million loans, and these are loans that were in mortgage-backed securities. So they're pretty volatile. They are an absolute, they're a gold mine for trying to build high stress scenario credit models. So the goal here at the end of the day is to be able to take a borrower and score them for how we think they're going to perform. So do we think they're going to default? If they're going to default, what kinds of scenarios would trigger that? And build a probabilistic model over those scenarios so that we can assess risk in-house, and then obviously price them accordingly. So I'm going to speak to a little bit of the similar examples to what Colin showed on our data set, where we took okay, great. So this is the typical FICO score, right? This is the FICO score that is run every time you apply for a loan, a substantial loan, and mortgage companies actually typically weight this thing pretty highly. And so what you're seeing here is it shows off kind of a lot of things in our analytical pipeline that really make a difference, things that we like to explore pretty interactively. So I'm just going to kind of walk down the top of this very dense slide. You see the very light gray bar that reflects filters. So these are different stratifications of data that you might want to sort of run an analysis on, or maybe you just want to do an ad hoc exploration of what's in the data set and how does a factor look given some condition. So for example, the first couple of filters you see, this FHFA, HPI, that's a really long acronym that just means the Federal Housing Authority's Home Price Index. So we essentially want to limit the loans that we're looking at by loans that actually have we've matched to a price index, which lets us analyze what happens to the underlying asset on the mortgage within 12 months. We're looking for loans that have FICO scores that are actually in the legal range of FICO. This data set is notoriously noisy, so there are some FICO scores in the hundreds, which is just illegitimate, right? It's somebody who made a data entry error. There are FICO scores in the 10,000s. There aren't that many of these, by the way, but if you throw something like that into, say, a Gaussian mixture model or something, you'll get a mean, and those points that are big-time outliers will pull the mean. So you can just exclude them with a simple filter in Looker, right? I mean, normally, if you don't have a tool like this, you're probably writing little bits of code, and your code will, your code where you have very nice sort of clean statistical models will live right alongside a bunch of hacks that you've had to build up to filter the data. And then there are other more meaningful filters, right? Like we're only interested in this analysis for loans that are in first lien positions, so second mortgages are kind of irrelevant. And then we have the way that we've cut up the data, the FICO is split into buckets, right? So we're not looking at continuous FICO values. We've been able to overlay a histogram of 50-point increments in FICO, and that's a thing that is literally one line in Looker. So we paste that one line in where we want to do 50-point steps in FICO and hit run, and we can easily look at how many loans defaulted, which are the three columns in orange that are on the left or on the right, and which loans did not default. And we can sum up all kinds of interesting things, right? Like how much capital was deployed within those FICO bands, how much loss was there as a function of principal. And we can also visualize that as well. So the plot shows sort of a graphical representation of what's in the table. And you see that FICO is definitely a normal distribution, but and in fact, like it's really hard to tell apart what you would do with just FICO as an originator, right? As a mortgage originator. We can't go on FICO alone based on this plot. And in fact, as a modeler, like you'll look at something like this and say, well, yeah, there are all kinds of representations I could use for FICO. I could use a Gaussian mixture model. I could use just Gaussians. I could maybe do nothing and just discretize and use them as counts. But they're not going to give me too much separation because the ratios within each bucket for loans that did default and loans that didn't default are pretty much similar, except at the very, very highest number. Looks like people that have over 750 FICO and maybe over 700 FICO are much less likely to default. But that's the sort of thing that that's analysis that you can get literally by just looking at this graph. So let's look at another one. This is a pretty similar kind of filter and explore, but this is on a thing called DTI. So DTI in the mortgage industry stands for debt to income, and this is just a general credit term that essentially is the ratio of, if we're going to give you the loan, the debt is the amount that you're going to pay, and it's a ratio of the debt to your income. And this can be calculated before accounting for other debts or after accounting for other debts. And typically in mortgage, it's calculated after other debts. And so when we're looking at DTI and we see that there's most in the data, most of the people have under 10% DTI, that would suggest that most people in the data set have, or most people that get mortgages have the mortgage is less than 10% of their monthly income, which just seems crazy. So we were able to identify that what happened in the data set was that there was unreliable data around DTI, and so we just couldn't use it. Much like the canceled equals loans that take off at midnight example Colin laid out. But this is something that would have been really difficult to figure out or it would have taken time, right? It just would have taken time and work to figure out without some kind of exploration tool. So we essentially do this every time we want to spin up a new model and think about feature selection and feature engineering. We can do it all inside Looker with a few clicks, no code.
Yep.
Which is great.
And I think one of the keys as well is that kind of for some of these variables, and I'm not sure what kind of your data set looked like here, but for some of these variables where you're looking at ratios or kind of thresholds or things like that, you do want to model the data kind of as early as possible on row level data so that you can explore these kinds of relationships. So kind of if canceled is stored in some separate database, or if kind of loan values are stored in one place and the debt amount is stored in another place, you want to join that together pretty early so that you can explore these ratios kind of directly in the database.
Yeah, that's exactly right. And we have, just to sort of piggyback on that a little bit, we've overlaid this home price index onto our historical loan performance data. We've overlaid census. We overlay rent index. We overlay a lot of things so that we can pull in different data sets very easily, right?
Yep. Okay, so to circle back to my previous example, I just built a very basic binomial predictive model in R where I took carrier origin and flight time. And as you can see, it doesn't do a particularly good job of predicting flights that are going to be delayed. So we probably don't have a product that we can sell here. But kind of the general idea is that a lot of times once you build your model, kind of the evaluation process of your model on an ongoing basis can be relatively difficult. So my very simple workflow slide for how we evaluate a model is that we do some analytics. We might clean our data while we're doing that, pop that into our modeling tool. But kind of maintaining this cycle on the left-hand side where kind of we're doing analytics and then modeling and then doing analytics and then modeling is something that can really improve our modeling on an ongoing basis. So in our flight example, what we can do is actually take the output of our model and push it back into our analytics tool. So even if you're not going to productionize a model, maybe if you are going to productionize a model, what you're going to want to do is continue doing all of those analytics you were doing before on the model. So in our example now, we've got our flights percent on time and our forecasted percent on time. And we can do our very basic slices where we're looking at carriers again, we're looking at departure dates, we're looking at departure months. And this is something that we're going to continue doing on an ongoing basis because our model is not static. The data is changing over time, and we need to observe that these trends remain static. And that's not something that you're going to be doing in a modeling tool. Downloading data, pushing it into a tool, redoing models is difficult. If you've got this forecast that you can build into each row level item and you can start observing that on an ongoing basis, you can actually set alerts, you can observe things over time, you can do very basic trend analysis. So in our example, we can look at residual data. You can obviously do this in your modeling tool, but doing in-sample and out-of-sample testing on an ongoing basis can be tiring. You need to pull out your data, push it back in. Whereas, again, if your model is built into your databases and you can just observe things on the fly, so you can see we didn't use time of day, and our model does degrade throughout the day. That's to be expected. The top graph is just by year and month, and we can see that our model does relatively okay here. But in our example, if we go way out of sample, what we can see is actually that our model degrades pretty significantly over time. So I just used this pretty small sample set, and then we observe the prediction of on-time rates over time, and we've also got this ongoing actual level of on-time rates. So what's happening here is that we've actually set up in production this on-time prediction. You can kind of imagine this in real time. We would have some sort of ongoing prediction. We're predicting each individual flight as it comes in, and we can observe this data on an ongoing basis. And we're not pulling it into a modeling tool to do that. We're actually doing it directly on top of our data. So when we do need to productionize data, what we can do is do all of our analytics just as we were doing before on data in real time. So Justin, you want to tell us about how you were doing that?
Yeah. Here's an example of our credit model that I was sort of walking through in the previous slides. And the joke is that you do about 80% of the work to get the features out of the data, and then you do another 80% of work to figure out what your model is telling you. And so here I've just built a basic confusion matrix in Looker. If you notice in the filters, I've got this prediction version starts with V4. So when I load models back into Looker, I will mark the predictions or mark the model that I ran with a particular version. So I know what data set I ran, what the data set was. That was a training set, the validation methodology, the algorithm that I used, the feature set. It's all matched actually in Looker with another table that I can query against to get those values. And so what you see right off the bat is that I've got a filter for what probability we will accept a loan at, and if we don't accept a loan, which is the first column, the first three columns, then we want to see that's us rejecting a loan, right? We're saying this borrower is probably not likely to pay, and what you'd like to see is that in the data that was an accurate prediction, right? So the true positive rate is this count percent of total. It's 85.5. So this is actually a particularly stressful example. It was loans mostly in the Southwest and West Coast, so California, Arizona, Nevada, and loans originated in 05, 06, 07. So this was the crash, right? And you can see actually how bad the crash was by the total return and over total principal. This is saying that those loans essentially lost 35% of the principal, and in mortgage that's that's a ton. That is an absolute massive loss. But we were able to catch 85% of those with this model. And as Colin's mentioned, this model alone is, if you just sort of hand the weights back to an underwriter and say, okay, now when a borrower comes in, evaluate against this model. I'm going to give you a score, and I'm going to tell you what factors are important. That's a pretty difficult thing to do business-wise. That's actually really hard to act on. So what we can do in Looker is easily pull out what factors went into the model and see where the needs are in performance vis-a-vis each factor. So that's a nice way to build intuition around what factors the model might be learning. On the positive side, right, we can see that on sort of the bottom right, we during that time would have taken 45% of the good loans. So that's a good thing. But being able to easily do this kind of analysis is also like another batch of code probably after you've built a nice statistical model. That's just kind of a hack, and anytime you want to do another bit of exploration on top of it, somebody's going to have to come and talk to you about what you want to explore. You write more code, and it's a really, really inefficient loop. But this here, in Looker, right, it's web-based. Everybody in the organization can see it, so anybody can explore the data. Our business users can explore, the output of a random forest or a support vector machine, and it's simple for them. And by the way, that's not what any of these are. Those algorithms actually didn't perform too well on this data set, on this particular data set. But you can run those, push them back in with a version, and compare them to one another as well.
So how do you approach kind of type 1 versus type 2 error in terms of kind of acceptance rates and things like that?
Yeah, it's a good question. So that's actually a place where we like to do some offline analysis as well as stuff inside Looker. But we have, so the standard way, right, is to look at something like an ROC curve and think about, which errors are acceptable, or what's an acceptable error rate, and pick that sort of operating point where you can say, yeah, I'm willing to originate, and I'm just making up a number here. This is not our number, but 7% defaults, right? So you have a threshold, and that's how I actually picked the threshold for this default probability accept, right? So you get a probabilistic model, it dumps out some score, but you got to make sense of the score somehow. So that's kind of the methodology, but it's a little bit more nuanced for mortgage, and I'm reluctant to show too much of the special bits that we do. It's more nuanced for us because we have to consider payout to investors as well, right? When a person invests in our loan and they're willing to take a little bit more risk, that has a very different risk profile than someone who doesn't want to take much risk and has a lower rate loan that they've invested in. So it's more nuanced than an ROC curve, and that's about all I can say.
Yep. So kind of that was mainly what we wanted to cover today. We wanted to kind of open it up for questions for people that had specific questions about things that we covered during the presentation.
Okay, great. Thank you, Colin and Justin, for that presentation. It was very interesting to see how it ties into a specific industry like lending, and also some of your examples with the flight travel stuff. We did have some questions come in. I'm going to encourage our audience to continue to ask questions as we do have time. On your screen, you'll see both Colin and Justin's email information, so you can contact them following today's presentation if you do have additional questions that you'd like to ask them. And again, feel free to ask as we continue with the Q&A for the remainder of today's event. So Colin, the first question I think is more directed at you. With regards to the flight travel estimations, one of our viewers and members today was asking if you were to add the destination, if you were to add something like weather to the destination in that kind of line item, are you able to add additional?
Yeah.
Yeah, you get where I'm going. I'm sorry, I'm stumbling with.
Yeah, like additional data sources and things like that.
Yes, exactly.
Yeah, I mean, whatever you put in your database, you can model up in our analytical tool. So we're querying the database directly. But if you have additional data sources and you have ways to stitch them together, you really could model it on top of anything.
Okay.
And weather would presumably be a very effective.
And as many line sources as you'd like, or is there any limits to it?
No, I mean, it's got to be in your own database.
Right.
But we're on top of your databases. Anything that your database can handle, we're just helping query your databases directly.
Got it. Okay. Very good. Next question is, how does Looker differ from OLAP, I guess, OLAP tools like Cognos and MicroStrategy?
Yep. So we like to say that we're a more modern version of a lot of those tools. All of them are behaving similarly in that they're mostly querying your databases directly and that you're modeling your SQL data. But kind of we're heavily browser-based. We're a more modern architecture into the database. We think we have some special sauce around the way that we're querying and kind of different database supports and things like that. But it's a very similar tool in that sense, but it's browser-based, it's web-based, it's shareable. It's all done in the links, so you can share links around an organization or things like that. But from a data modeler's perspective, for someone kind of modeling on their own, it's going to look very similar. We use an internal code called LookML to do a lot of our modeling as opposed to more visual modeling. So it's a little bit preference-based, but kind of we think of ourselves as a more modern version of a lot of those tools.
Okay, very good. Similar to that question, is it necessary can you use other tools like R and Python along with it, or do you need to? How would you incorporate other methods and other tools that are out there?
Yeah, I mean, a pretty typical workflow that we see, and maybe Justin has thoughts on this as well, but is that people do this level of exploration on the top, and maybe they don't even do the more complex data science on the back end, but they're using Looker to explore their data. And then when they do want to model data, they're either using SQL outputs to spit out CSVs or to send data into their tool that's kind of pre-shaped, pre-modeled, and then doing the analysis there and pushing it back into their databases. So kind of the tools talk to each other more than anything, but they're not kind of directly interacting.
Okay, very good. What other tools, let's see, what would you recommend to clean the data in terms of tools and process? Can you give more details on that?
I mean, it sort of depends on what you mean. I mean, Justin, you want to kind of talk about the data cleaning stuff?
Sure. I mean, I think that the reality is that data cleaning is just messy and it takes time. So for us, we had some intuitions about what features we think make Alone perform, and we wanted to explore all those features and just get a sense for which ones were noisy, which ones weren't, which ones matched a particular distribution that we expected or didn't, and that's the process. And so, and if I were just using something like MATLAB or R or Python, that would be a bunch of ad hoc scripting, right? I'd load the data up, and I'd say, all right, I care about LTV. That's column 4. Okay, so then I slice out column 4, and I reshape the data and maybe I say, well, I wonder how this would perform as a continuous variable. So I would just plot that, and then maybe I say, well, I'm not really interested in it as a continuous variable. I'd like to model little chunks of the data, so I'll discretize. And you just sort of build a loop like this where you're writing little bits of code, and then you're looking at the output. And the problem with writing little bits of code is that even writing a 10-line bit of code can be a challenge. You can make mistakes. But I think exploring in Looker is, the LookML generates SQL for you, right? So if you've built the right composable little pieces of SQL, then the tool is going to generate good code for you, and you don't have to worry about breakage, right? So you can just have a much faster exploration time.
Yeah. And kind of to add on to that, I think one thing that we see a lot is that there are data modelers that are working with data and they're cleaning it up and they're shoving it into models and things like that. But if you just have to go and clean up your data again to ask a very basic question, you're kind of wasting cycles. So if the data is cleaned up kind of on the front where everyone is using this cleaner data, then kind of everyone can take advantage of what the more analytical people have to do to clean up data to explore it. So Justin's work is reusable across the organization as opposed to just good for his credit model.
Very good, thoughtful answer to that question. Justin, this is probably more for you. So the question is, who and how did Looker get implemented and deployed into LendingHome, and was it done exclusively by you and your team, and how much was Looker sort of involved? I think they're looking to get information about what's involved, the process, how long it takes, how long does it take to get sort of up to speed and using it in day-to-day activities.
Yeah, it's a good question. The Looker has an analyst team that is pretty good. You can get up and running in a matter of minutes, I would say. You just need to point Looker at your database, and it can automatically generate models from all your tables. And you will need to go in, and if you have special relationships between tables and you want to customize the joins, I would say that's where a lot of the work is. So there's sort of a careful step where somebody who knows SQL or knows the data model well and can work with Looker's analytics team. That's sort of step one. And the other step is getting familiar with the sort of the LookML, the different reusable snippets of code that Looker is going to generate for you. For example, all the date handling, right? If you want to, for example, be able to cut data by month, week, day, hour of day, that sort of thing, Looker has nice abstractions for that, but you just got to learn them. And so the analyst team can help you with that, but the documentation is also very good. So for us, once we really dug in, I would say it took us about a week to really be off and running with Looker. Oh. And not just like walking, but really running and adding significant sort of bits of analytics to our data.
Well, very interesting. Thanks for sharing that with us. Along those same lines, are there other tools that you're using in the workflow? And this could be a question for both of you with just general data modeling workflow. Are there other tools that you would recommend that might speed the process up?
For me, the main two for me were kind of SQL/Looker and R. That's just kind of where I'm most comfortable. I don't know about you, Justin.
Yeah, I'm pretty comfortable in a lot of places, but for us it's mostly Python, MATLAB, and Looker.
Okay, well, in the same sort of vein of that question, do you need to know SQL well to make Looker work? Does that need to be sort of a core competency?
I think you need to understand the general concepts of SQL to work with Looker. You don't need to use SQL on the front end. Kind of exploring the data looks much more like using Excel. But to do kind of the heavier modeling, the things that we were talking about around reshaping your data and kind of developing your Looker model, you're going to want to know SQL.
Okay, very good. So can Looker work with data on flat files like HDFS, or is it for data in relational databases only?
Yeah, that's a good question. So essentially, if a SQL-like engine can query at the data, so on top of HDFS, you've got stuff like Hive and Spark and Shark, things that can interact with HDFS data in the way that SQL does, we do work with, and we're still young there, so we're working on a lot of our tools around that functionality. But kind of anything where you're writing SQL, it doesn't have to be relational to actually get at that data.
Okay. Can you maybe explain a little bit how the data is being piped back and forth between something like Looker and R?
Yeah, maybe Justin, you want to?
Yeah, sure. So Looker has an API that you can fold right into your code, and so that's what I use to get data out of Looker. For every one of the queries that you for every query that you do in Looker, you can build a corresponding API query that does exactly the same thing, and so that's what our process typically looks like. I mean, these Looker queries that unload and reshape the data end up looking like configuration files. So you sort of have one API call that matches a query in Looker that's some cut of the data or some set of features that you want to chop out and do an experiment against. And so that's what it looks like on the input side. Looker doesn't have much on the, as far as like pushing data back in, but I tend to create just very, very simple files that take examples. So, I mean, just think of each example loan that you want to do a prediction on. You've got a loan ID, and you store just the loan ID and the prediction, and that's it. If you do that and push it back into the database and join your predictions table on the loan IDs, then you can get all the features that went in to doing prediction over the loan and look at the output of the model. So it's really that's kind of the loop for me. It's use the API to do all of the to essentially pull all the data out and have a very, very light loader that pushes the data back in and explore from there.
Okay, very good. Justin, another question for you is how do you share the data with the other folks within your company?
Well, so one thing that I think got kind of chopped off on some of our screenshots is that all of these screenshots are of inside a browser, right? So everything that you look at is a link that you can just share with other people. So that's the way that I do it. It's typically emails or saved queries or dashboard versions of some modeling run or some kind of analytics we've done, and send them a link, right? It's very simple and lightweight.
Okay, sounds great. So we're pretty much done with our questions. Before we wrap up, Colin, is there a demo or a place for our audience that you want to maybe mention that they can try Looker out to see what it might hold for them in terms of
if you just go to looker.com/trial, we'll put you in touch with someone that can walk you through the service in real time.
Okay, very good. I think some of the folks were asking a little bit more to maybe see some kind of demo action, so if they can go there, that might be a good opportunity for them to sort of see it in some different industries and different sort of models, if you were. So again, thank you to our audience for the questions provided and attending today's webinar. I have just a few quick announcements to make before we wrap up today. Please join us for our next webinar on November 11th, which is Data Transformation and Acquisition Techniques to Handle Petabytes of Data, sponsored by Hortonworks and Oracle. Also, as I mentioned, this webinar is being taped and will be placed onto DSC later on this afternoon. I'd like to do a special thank you to Looker for sponsoring today's event, and to both Colin and Justin for their insight into today's topic. It's been a pleasure being your host today, and I look forward to seeing you all again on November 11th. Good day.